Which one?
If it's on 2E where it says without replacement, so does that mean we're just like adding them up like individually without multiplying them together?
No, without replacement just means if I do one probability, the next one's going to have one less total, right? One less, just like we did earlier with the picking the poker chips one. We'll do it together here right now. Okay. Let me catch up to you guys. Hopefully this first one, maybe F gave us some trouble. Someday, I desperately wish you guys would see this. It's not nearly as crazy as it seems, I guess. To see if two things are independent, like an A and B, I see, okay, it's probably A given that B. I need to see how they interact with each other. I can't look at probably A and probably B separately and go, well, they're not equal. That doesn't have anything to do with anything. How does one affect the other one, or does it? That would be A given B. Is that different or the same as the probability of A by itself? If it's different, they're dependent. If it's not different, they're independent. They don't care about each other. That's really all there is to that. And you're all like, yeah, it's easy for you, Jeff. Right. Let me see. There you go. So let's see. Let's start up here. So let me do this real quick. Let me see if I can. Come on, math boy. Is that right? 50? 176? That sounds right. So, you've got to look at it like this. Basic probability is how many things could happen. I know in this case it's people. So 176 people that could happen. And out of those 176, how many chances do I have to get the what I'm looking for? 126. And somebody, what do you get for a decimal there?
71.6.
Who?
71.6.
0.716?
Yeah.
Okay. And then you make it a percent, whatever. I don't care about that. Is a business major. And by the way, hopefully I didn't see anybody that thought these kind of built on each other. They don't. They're each separate things, right? So let's start over again. Is this business major? Well, again, out of 176, what's the only time the bottom will change? If there's a given. If there's no given, then it's got to be out of everybody. It could be anybody. I don't know anything about them, so I can't throw anybody out. How many out of 176 are business majors? 92. And then that's, what's that roughly?
0.523.
0.5? 2?
Yeah.
Sure. Okay. Blah, blah, blah. So on a test or, on the quiz, I'll say how many decimals to go out to, decimal places. Here you can go whatever. Is a computer science major or attends Grossmont. You could use the formula, or you could do this. I got to include all the Grossmont people, right? All the 126. Now, how many computer science people have I not counted yet? Those 11. So you get 137 out of 176. Now, you could do 126 plus 73 minus 62, or I could just not count the 62 twice in the first place. Maybe. Either way, hopefully you got 137 out of 176. And what is that roughly?
0.778.
778?
Yeah.
Okay. Now, or is the nice thing. Or always makes the number bigger than it would have been on its own, either way. And always makes it smaller than it would have been, either way. Because you got to meet more and more requirements. That's what and means more and more. So not only do you have to be a math major, that's already down to 11. But you also have to be a Cuimaca student. That just leaves you with 2. There's only 2 students that go to Cuimaca and are math students. They have to meet both requirements. So if you start saying 37 plus 11, well, no, those students aren't math majors. Why are you counting them? You have to be a math major and a Cuimaca student. So 2 out of 176, whatever the hell, I don't care. Sorry. is a Grossmont student, yeah, given, of computer science majors? How many people could it be? Yeah, it could be 73 people. Computer science majors is only 73. And how many out of the 73 match what we're looking for? 62. So remember before I was saying that's your universe now. Because you're only talking about you're given that the computer science major. So our being a Grossmont student and a computer science major, are those independent? Compare the probability of Grossmont to the probability of Grossmont given computer science. That's what you compare. Right? I want to see how, knowing you're a computer science major, does it change the probability of Grossmont student? If it does, that's dependent. Please let that make sense. That means that one probability depends on if the other thing happened or not. That's really where the word dependent comes from. So sure enough, I made you do those two probabilities, right? With 62 divided by 73. Who is it?
84.9%.
84.9? So it was 71.6%. It becomes 84.9%. So they're totally dependent, right? Knowing they're a computer science major, does it change the probability they're a Grossmont student? Hell yeah. Right? In this case, it goes up. Right? And when would you do, this is what's called conditional probability. On the condition that this happens, what's the probability that this happens? You use this kind of thing all the time. In fact, that's how we start to analyze, well, given that you eat this way, what's the probability you get cancer? Or given that you live here, what's the probability that, well, cancer again, shit. But we do that all the time to see if there's an effect between two things. Like it, maybe. So no, they're not equal to each other. 0.716 does not equal 0.84, whatever you said.
84.9.
Blah, blah, blah. So, dependent. These have to be equal to each other for them to be independent, for them to not care about each other. Maybe. I always get people answer this question with a little paragraph of words. It's not good enough. This has got to be a math answer. Not just because I'm a math guy. It's just the way it is. Okay, how are we doing so far? I would love to put all of Congress in a haunted house. If we, so there's 7 Democrats, 12 Republicans, and 2 independents locked in a haunted house just because. Some stupid reality TV show. If we pick one person at random from the house to save, find the probability that person is a Democrat, well, okay, it shouldn't be too bad. Yeah, you got 7 chances to get a Democrat out of 21 people. So that reduces to 1/3, so 33.3. Everybody cool so far? Probably the Republican would be 12 Republicans out of 21, which is 4 out of 7, whatever. Blah, blah, blah. I like it. Remember, if you don't show me this and you just put a decimal down or something, if you get it exactly right, I'll still be like, where's the word? But if you get it wrong at all, you lose all the points because I have no idea what went wrong. This is the work. Creating the ratio is the work, and then you can do whatever you want to with the ratio. All right. Now we select 2 people with replacement. So that means that the denominator is going to always reset. Everything's got to reset. So we take 1%. Oh, thank you, and then we put it next one. Probably the first guy is independent.
Up, Jeff.
Up. You're in
You're
without.
in without.
Who is it?
You're in
You're in
without.
Oh, Jeff. Thank you so much. All right. First one's independent would be
221.
2 out of 21. And
1221.
times Republican, 12 out of 21. Whatever that is. What is that? 441? Is that about? 24 out of 441?
Yeah.
And whatever that is.
5.4.
Who? Oh, 5.44%.
Yeah.
Okay, make that. And by the way, real quick, if you get an answer like 113%, don't leave that there. At least say, I can't see where I went wrong, but I know it should be over 100%, Ms. Waller, and I'm not going to start just crying to myself. Right, just please. So I was worried for a second. It can't be bigger than 1 as a decimal, but a percent is beautiful. Right, so don't tell me the probability is 300%. Holy shit, it's so going to happen. It's going to happen 3 times. I don't know what the... 2 Democrats, so the first one's a Democrat.
721.
721, and then the second one's a Democrat. And that's 1/9, which is 0.1111111. 0.11. How we do? 11.11%. Yeah, 1/3, 1/3. So this one, it starts off the same way. I like to do this kind of thing. It just makes it a little easier, I think. Same questions, 2 out of 21, but what happens to this one?
12 out of 20.
12 out of 20 because we lost the person. Yeah, whatever the hell that is. What do you get?
24 over 420.
5.71%, okay. So it changed just a little tiny bit. If I do it without replacement. And then 2 Democrats, what would that look like? 7 out of 21?
620.
6 out of 20, I love it, because you lose a person and you lose a Democrat. So the top and bottom change. I always get somebody to say, why did you change the bottom there but not over there? It's just because we're picking the same thing twice. And we're not replacing it, so we lost one of them. Whatever that is.
10%.
10%? Sweet. Yeah, 1/3, 6/2. All right, I like it. So 9% of Americans have a favorable view. This is a place where it's not a bad idea to summarize things with symbols. So if I say probability of n, let's say probability of n means 9%. What's 9%? As a decimal. 0.09. So what's probably the first views North Korea favorably? That'd be n. While the last 3 don't. And I always think of this like a hangman game. I got 4 spots to fill. Does it look like my little faces? You see the hangman game going on here? I got times in the middle because if you don't, that's okay. First one views North Korea favorably, and the next one doesn't, and the next one doesn't, and the next one doesn't. So there's that hidden and in here. So the first one views them favorably would be 0.09. What's the last 3 don't? Each one is going to be 0.91, 0.91, 0.91. You could do 0.09 times 0.91 to the third because I got 3 that do this. Who is it? 0.067. Now this one, oh shit. Let me see. Here we go. You got some paper, Jeff? I don't know. Sure. Now watch. If I ask people, do you own a TV? How many TVs do you have, right? So let's say some people say 0, some people say 1, 2. Let's just say they go up to 3. Okay. And let's make this easy here. 0.2, 0.3, 4.1. What was I just careful about? What are these, do you think? Percentages. So 20% don't own a TV. So what did I have to be careful about as I made these? That they added to be 1. Or 100% is a percentage. Is everybody with me so far? What's the probability that somebody doesn't have a TV? 20%. What's probably somebody has at least 1 TV? You could either add these up, or you could say it's 1 minus the 1 I left out. Do you guys see that? If they add up to be 1, and I want to know the probability of at least 1, I could either add these 3 up, or I could do 1 minus this. Because of course it's going to equal this, because altogether they make 1. So probability of at least 1 is 1 minus the probability of none. Probability of something is 1 minus the probability of the opposite thing. And what's the opposite of at least 1? If I said at least 1 person in here watches Game of Thrones, you think I'm wrong, you have to show me that nobody. That's the only way I could be wrong. Anybody watch Game of Thrones? Shit. God. better about the time period you live in. In fact, there's no dragons. So the probability that at least one views North Korea favorably is the 1 minus the probability that none of them view North Korea favorably. And why is that better? I want you to really get this. If I tried to do this directly, it would so desperately suck. How many ways is there for at least one to view North Korea favorably? The first one could do it. Or, oh shit, now so I can do the first one and the last three don't. Or, the second one and the other three. Or, the third one and the other three. Or, the last one and the other three. Or, the first two and the last two don't. The middle two and the three. And I'd have to do all the ways that match what I'm looking for. How many match at least one? A lot. So I'd much rather do 1 minus the probability of none, because how many ways can you have none? One way. They all don't like North Korea. That's the only way. So a ton of work versus very little work. Yes, please. Right? So this happens all the time, this idea of at least one, and you just look at the opposite so you can make it quicker. So how do I do none? I want all four to not like them, right? None of them to like them. So each place is going to have I want them to view them unfavorably, not like them. So 91, 91. Whatever the hell that is. 0.8, 0.7, 0.63, 0.3. What would it be? I'm not sure which way it would go. 0.34. I probably went too far. 0.3. What is it? Did I do it anywhere near right?
0.314.
Who is it?
0.314.
Oh, cool. So 0.314, yeah. Double check. Just to remind you guys, it's not the only time we're going to talk about this. The next class is going to include a review, obviously, because I'm going to have the answer key for this side on Wednesday. Now, this last one's probably the weirdest problem on here. If we also know that 6% of Americans have a favorable view of both North Korea and Brussels sprouts. North Korea and Brussels sprouts is 0.06. What else do we know? We know that probably North Korea, that they view North Korea is 0.09. And I want to know the probability that they like Brussels sprouts given that they like North Korea. Well, what would that formula be? So see what I just did. This is going to happen in the homework. I just gave symbols and assigned them to numbers that are coming from the problem. I'm going to use the same symbols to set up the question so I know where to put the stuff the problem tells me. This is going to happen a few times in the homework. So what's the formula for B given N?
N and B over.
And N over probably N. What's probably B and N? 106. Probably then 109. 6/9 is 2/3 is 66.7% roughly. Whew. All right, I think that's enough. So next time I'll have an answer key to that other side of this, like I said. Keep on doing homework.